we did not have any MATLAB, but after that it started to work again. So the university purchased the license. Just they forgot to tell about this. So again, you can, after registering an email address at STUD, so a university email address, then you can use MATLAB for free with all the toolboxes. So today I would like to show you how can we do basic things in MATLAB. So first, this one. So this is how the software looks like. So this is where we can write the code into the editor here. And after installing the software, you don't have editors. So in the home menu, you have to click on New Script, and then it will create an editor. This is where the current folders content is located, and then we can see that contains things here, and also we have the workspace here. This is if you are loading in any Excel sheets, then or any kind of a data, then all the calculations, results, and all the numbers will be located here in workspace, in matrices and vectors. And in the command window, we can find results, error messages. So if it's black, then it's result. If it's red, then it's error message. If it's yellow or orange, then it's just warning, but it's still running. So these are the all the necessary information about MATLAB. Obviously, there is a save button, which is a nice thing. And also, if you need any help, then we can use the documentation, because the documentation contains all the description of the different functions, examples. So the whole, literally the documentation is inside there, so you don't have to buy any book describing MATLAB, because the documentation is itself operates as a book. Okay, so last time I tried to talk about the basic statistics and why we should focus on them. And today I would like to show you that how can we do this automatically. So how can we write a script which measures all these things immediately, and we don't have to do the same thing again and again whenever we are using a different time series. So last time we had very different times. What is this macro model? USD. Yeah, okay, this is what I was using. Yeah, but this is only one data set, so it's not many different columns for data. So instead of this one, let's check. Okay, so we have input data for ECB's monetary policy. It's quarterly data before COVID and right before the global financial crisis, so we can have interest rate, output gap, inflation gap, and other funny things. And also we have daily stock market indices and currencies. So maybe this one can be also useful. So, if we are doing anything, in MATLAB I have to increase first of all the font size. In this case you can see it. So here we can do it in preferences, at home menu, then fonts, and 18 is usually the size what students can see. And so if you are using percentage marks in MATLAB, then this is what we can use for commenting. So this is not part of the script, this is part of the documentation itself, because in this case we can see that what we are doing here. So 0 step, loading the data, and here we can, it's always better to start with a clear command to clear workspace. Because if you are running again the script, it's much better if you are not overwriting things or letting things here accumulating up. Because in the past I was able to get really strange results because of this, so it's much better to be keep it clean. Okay, then if we need to download or use this data, so the Econometrics 2002 file, 22 file, then we should just save it into the documents MATLAB folder. And after that, we can see that, okay, it's there. So if you are opening MATLAB, we can see that, okay, it's here. So we could just load it in by grabbing it and putting it on workspace. That would require manual labor, and at the end of the day, sometimes it's not able to read in text data, so dates are usually ignored by it, so usually I'm not doing it. So it's much easier to say that, okay, data equals XLS read, quotation marks, the name of the file, and also we should decide that which one should be added. And in this case, let's just say that we will use the daily sheet. So this is which defines the sheet. This part is of the function which defines the Excel file. We should use this quotation marks. It can be double quotation mark. In the past it was just single quotation mark, but I think that now it works with both. And so that's all. This is the name of the function, and this is the output. So this is the general structure of creating MATLAB functions. So F9 for running. The part of the script. Yeah. So in general, in MATLAB, we are always using the same or similar fashion. So there is the output on the left side of the equation mark, then there is the function name, and on the right, within a traditional bracket, we find the inputs. Input 1, input 2, and so on. And it's always ending with a nice this is the semicolon. I always terrible in these markings, but okay. So this character says that the line is ending, and in this case it will not write out all the sub-calculations. model of functions. Okay, so we have the data here now in the workspace. And as you can see here, none of the columns are named anymore, so we can just see, okay, which number is the column, which number is the row, but all the other things are removed. And so this is just purely for calculations. Okay, so now what we need here is to replicate this one. So we need central moments, or at least some kind of an average. Then also we should see standard deviations, skewness, kurtosis, is there any normal distribution in the data, and let's check for autocorrelation, let's check for heteroscedasticity, and let's also check that is there stationarity within the data set. So let's produce just the required table, which is always required in any paper, and we have to do this once. So once the script is good, then after that we just reuse it always until the eternity of time. So here you can find already that there is a basic statistics M file which can be useful, or within the code here you can find also one solution. This one requires the free MFA toolbox. If we would like to use just the factory default things, then we can also build this one. So. But first, it's necessary to calculate the logarithmic return.
And what kind of data are in the data set?
So right now in this data set, as you can see, they are with yellow, these are US dollar denominated currencies and Bitcoin, which is something, not a currency. And this one is, yeah, these are different stock market indices.
Yes, okay.
But we can do the test later on this input data, which is containing quarterly macro variables. Yeah, these are time series, so you can see it starts in 2007 and 2019 is the end of it. So, yeah, these are quite simple things. So first we should produce log returns, because in this case logarithm will scale everything to the same level, which is good, because as we can see here we have different indices, different levels for currencies, so it's much better to use log. So until we are not using inflation, which can be negative in deflationary periods, or interest rates, which can be also negative during deflationary periods, we are okay by using logarithm. So return equals diff log data. So first we are using the logarithm, and then we are using the differential. So it's just the difference between each time. But this one is necessary. So from last week we know that it will create zero mean data set, but we know that it will do this, but still it's necessary for test it. So let's check for centralities. So first we should do the mean, then the standard deviation, then asymmetry, skewness, and we should look for TLS with kurtosis. So this is just simple statistics. Okay. So now let's do the mean. So in this case, let's just create an output matrix of nothing, and we start to fill it with data. So the first row and j's column will be filled with the mean of the red for the rows and j's column. And in this case, you can see that how can we define different locations within matrix. So the first coordinate is always determining the row. The second coordinate always determines the column. And practically we can put not just I or J, but many other things as well. So it can be a number, it can be a range of numbers, it can be obviously this I, and which is defined externally. It can be everything, it can be and so it can be many things. How we can do this. So in this case, I mentioned that, okay, for the first line of the output and in all the different columns of this output matrix, I would like to have the mean of the different columns of the return, and in this case I have absolutely no restrictions for the different rows, so the whole length of the time series must be added. Obviously I need to define the number of columns here, so 1 just for testing purpose right now, and once we did it, then we will test it for everybody. So can you run? Yes, can you run when I'm doing the write? And I think here, so we can see that, yeah, it's nearly 0, so still mathematics is working. Then we just have to do this several times. Then so this will be the standard deviation in the second row. This will be the third one. I think it's skewness. I mean the name of the function as well. The documentation starts to, yes, humans, okay. Obviously, usually people don't remember everything and all the functions, so that's why it's much better to test. Kurtosis is the same. And after that we can just run them and check that are they working, do they create the expected values. They are doing it, so it's good. Then, obviously we don't want to change the numbers here manually, because that would require labor and we don't want to do that. So it's much better to measure the size of the whole matrix, because in this case it doesn't matter that what do we load in. So in this case, we have to use the size. And in this case, if we just checking it in the documentation again, then it will show us that it will give us, so the first end result will give us the different dimensional lengths. So the first will be the number of rows, the second will be the number of columns. So if I'm just saying that, okay, let's and it gives us immediately that, okay, number of columns, 12, good. Number of rows, 384, okay. So now we can see that, let's go through all these things. So so it can be 1, so we can start it at the first column, then let's go through all the numbers until 12, or we can say, obviously, the number of columns. Because in this case it will be generalized, so it doesn't matter which data are we loading in this data, then it will be doing the same thing. Obviously, if we should use panel data, then we should still work on it a bit. So sometimes we have to also limit the not just the columns, but also we have the restrictions about the rows. So in this case, each country's data will be tested separately. So that's the key difference when we are running it for country to country. But right now, this is good enough. So if we are doing it, then we can see that now we have the output, which right now we cannot see many things, but what we can see here that none of them, what are you? So none of them are close to 3. This one is, what is this? Which currency is that one? Turkish lira. Okay, that's strange. Yeah. Now, we should have to add additional things like normal distribution, test. So this will be the Jargbera test. So for time series, normal distribution is always checked with the Jargbera test. I know that in statistics, for cross-sectional statistics, you learn different methods, but this is what people are using. So, and also you can copy and paste from the documentation, so you don't have to type in everything by hand.
Where is
Yes.
the head?
Here. And once it's loaded in, then it's just a secondary window. Yes. So if you would just run it without the for cycle, then it will just give us that, okay, for hypothesis is 1 and the p-value is close to 0, so it means that if we know the rules here, that if p is bigger than 0.05, then it's normal distributed. And in papers, people are asking for the p-value, not for the hypothesis value, so I don't know why it was necessary to put it as the first variable, but we have to grab the second one, so you come with us. So that's the 5th one. So you can see that we can rewrite output variables. Also, you can see that if we have multiple outputs, then we need these square brackets, which can be available with argr, f, and g. And yeah, put here. And otherwise, we don't need any further calibration. So we just have to know that, okay, this is absolutely not normal distributed because it's way less than 0.05. Okay, third thing, autocorrelation. This is the Young box. Test. Oh, actually don't know the result, but okay, this one is proper. So Young box test is also the most popular approach, and in this case we just check that if the p-value is bigger than 0.05, then no autocorrelation is present. And of course, for Young box test we have to define the lag numbers, which is where? Wow, what a disgusting approach. Okay, so lag numbers, which could be easily defined by some variables, it's not defined, so we should add one lag. Is this working this way? It is. Okay. And okay, so we need the p-value. I could say that why not adding more lags? I could add, but at the end of the day, what we need here is that do we need... So if this thing contains autocorrelation, that if we are using this variable in any kind of regression, then there is a high chance that the regressions, residuals will be also autocorrelated because we were adding autocorrelated things which had a memory for their past values. So if we know that this thing already exists, then we know that we will have to calibrate also the regression to include past values of the variable. So lag numbers will be at least 1. So this is just a red flag for us that, okay, should we be prepared mentally or not for such an endeavor? And let's see that. Do we? And it says, oh yes, okay, it's, you can say it's, but it's bigger than 0.05, but no, it's it's autocorrelated, so this is the so close gray state when we can say that, yeah, it's lucky and so on, but obviously it's just luck. Okay, heteroscedasticity. And I was able to type it down without a typo. Test. So this is where we can see that the volatility changes in time. So there are time periods when the volatility is high, there are time periods when the volatility is relatively low. So practically the market's ability to price in the asset is not stable in time. So if you have to work with regressions on it, then they are robust against this phenomenon, but if we have to focus on any kind of an issue with correlation or with a model which uses correlation or variance, then heteroscedasticity can bias everything. So that's why it's also a cautionary test for which I'm doing right now, which is free. And available for everyone. That's it also has the Q and robust parameters, but they are optional. So as you can see here, yeah, Q is maximum number, and robustness doesn't necessary to be added in. Okay, so from the two things, let's build up something for an illustration at least. So you can find MFA Toolbox here in the zip version, or there is, yeah, here in the zip version. So you can just extract it and use it. Okay, so now if we are checking the data set, then we can... Oh, there is one last thing. We need stationarity test. So... Okay, so people are usually using the ADF test, which is always considered as outdated, but let's add this one here. And also we can add ADF and Phillips Perron PP test. And there is also the EPSS test. Usually they are giving the same result, but since it's free and it's already there, then why not to use it? So we just have to add eight, 9, 10, and let's see that are you able to cooperate? Expected string, scalar, or character vector for. I don't need this one. Sorry. For parameter. They don't define the leg number. Okay, they don't define the leg number. Then can have it, just I don't like it. Ah, there is. Just one leg backwards, nothing more.
Oh, why you are choosing one?
Because we need to choose something, and it's always one leg regression. So I don't know. So if you are checking papers, then usually they are doing this in this way. So
now, is it checking for stationarity test, right?
yes, yes, yes.
So don't we need to add, for example, 4 or 5 legs?
Mm.
I mean, as kind of use, we choose like 4 legs in the beginning, and the result shows us what is exactly the number of the legs.
Yeah, if you are choosing to optimize the model by selecting the information criteria, then yes. But this one is not able to do that.
This is not a selection, right?
No. So you have to give something as a leg number. So in this case, using 1 leg is still more reliable than giving a range. So
I saw this select.
Yes. It's user select.
Mm-hmm.
Not the greatest approach, but this is what we have right now. But as you can see, okay, here with the KPSS test it starts to fail, but otherwise it has nice results. So let's pick output. And let's have the analysis. So this was main std. So that's this normal distribution. Autocorrelation, atheroscedasticity, ADF, Phillips Perron, and KESS for stationarity. So, okay, in the first line we know that ideal value should be close to 0, and in this case we can say that okay, these are close to 0, so it's okay. We don't have to write much about this in our paper. In the case of standard deviation, what we can see, we can do only the comparison that which stock market index is more riskier than the other. So this one, which is, what was it? That was from Jakarta, this one. I don't know which one is that one. But so this one is the riskiest. If we are checking the real currencies, fiat currencies, which is always hated by the crypto people, then we can see that Swiss franc is obviously the most riskiest here. And above this, by 1 level, we can find the Bitcoin, which is, you know, that is always superb according to crypto bros. It's not. So, okay, in this case, when we have the skewness around 0, it would mean symmetry in the data, and we cannot see. So the closest thing to the symmetry is strangely the Turkish lira against US dollar, which is strange. How does it look like? So this is usually depreciating like but the change is quite gradual, so there are no sudden upswings or downswings, and that can be the reason. So but it's really strange that we have this. And okay, this thing is going up with huge steps. This one is going upwards with bigger steps. So let's check for extremity, and we can see that there is a small number of extreme jumps in the Euro-US dollar market. In the case of Turkish lira. Okay, this is surprising. So maybe if it would just different sampling time periods, this would be a different result. But okay, right now this is what we have. But we can see that the rest is absolutely far away, and especially with the Swiss franc. Okay, with the Swiss franc, we have this problem that they were initiating this upper ceiling and then removing the upper ceilings. So these jump here and then backwards when they initiated the upper ceiling in 2011 September, and when they removed it in 2015 January, then obviously it created shocks, and that's why we can see with the naked eye that within 1 or 2 days changes are happening. So. The normal distribution, P should be bigger than 0.05 to have this, and none of them. Okay, we can say that this is so close. No, this is still under. Okay, in the case of autocorrelation, so there should be no autocorrelation. Sorry, backwards. Saying that this is autocorrelation here. So we can see here that there is something, but this one is a clear indication that there is no autocorrelation for the German DAX stock market index, for the SMI, which is I don't know what, also for this one. For the Turkish lira, and also for the Indonesian rupiah, and then.
But that one is above 0.5.
Yeah, this one is. Did I miss? Yeah, but that one is catchy at least. So okay, let's give a yellowish color, which is still so. That one. So until it's under 0.1, I don't like to say that now it's good, because in social sciences people are using 0.05, but also in many cases 0.1 as the threshold. So until you are within the 0.1 environment, then it's at least catchy. Yeah. Okay, but from heteroscedasticity point of view, we can say that these ones are good. This is meh. These are also quite good. This is again in the sketchy territory. And after that, as I mentioned, that logarithmic returns are providing us nice and smooth data, and I think I made some errors or mistakes in the KPSS test, because so maybe I should check the documentation, because right now it says that nobody except this one and maybe that one. But they are not good, so so we can say that okay, these are nice. Next big question is that okay, so first of all I should save this one before doing anything.